Hello, let me introduce you to a brand new product line from Bourns, our next generation GDT25 series that we announced in January 2021. This surface mount 2-electrode GDT protector is state-of-the-art. It uses the latest GDT technology generated from computer modeling. The most significant enhancements our Bourns engineers designed into the GDT25 series are the impulse response and surge withstand optimization they were able to achieve while also maintaining low capacitance in a wide, environmentally rugged GDT surface mount package. These features and capabilities represent some of the best datasheet specifications in the industry, with testing to confirm the device's performance to back up those claims. We're excited to present this advanced new GDT product. In addition to the GDT25 series state-of-the-art low-impulse spark-over voltages, DC voltage, and low capacitance, this device offers superior current handling capability for AC and DC waveforms, and excellent performance across a wide temperature range. Customers will particularly value these low-impulse voltage spark-overs that will allow them to use lower voltage-rated components downstream, which can potentially help them reduce the entire bill of materials cost. The low capacitance of the Bourns model GDT25 also makes it ideal for use in high-speed and high-frequency applications. The initial offering is available in 4 voltages: 75, 90, 50, and 600. But we can easily tailor the voltage range without a redesign to be anything a customer needs within the 75 to 600 volt range. Comparisons against competitive GDT benchmark datasheets demonstrate how the model GDT25 series is superior. The typical 8x20 surge current rating for 10 surges, which is a standard measure for grading GDT devices, is 5,000 amps. The model GDT25 has a 40% higher rating at 7,000 amps, and that's a significant difference. The next size larger standard GDT is 8 millimeters in diameter. These GDTs have a standard surge rating of 10,000 amps, so the model GDT25 is about halfway there. When evaluating high-speed impulse response, typical 5mm 90-volt GDTs have an impulse breakover voltage at 1,000 volts per microsecond of 600 to 700 volts. The model GDT25-09 is just 500 volts. The 10x350 surge test is a fairly new waveform, and a lot of GDTs aren't even rated for that capability. The 5mm tubes that do carry that rating are typically rated at 500 amps, whereas the entire model GDT25 family can carry a full 1,000 amps. Suppliers typically list their GDT capacitance as being less than 1 picofarad. The capacitance of Bourns model GDT25 devices is less than 0.6 of a picofarad. The average AC power cross-current capability for 10 1-second bursts is 1 second for 5mm tubes at 5 amps. The model GDT25 family is rated at 7 amps. Most 5mm GDTs have an operating temperature range of -40 to +90 degrees Celsius. The model GDT25 series has an extended range of -55 to +125 degrees Celsius. Bourns leveraged their extensive GDT engineering expertise to design these improvements in standard gas tubes using sophisticated computer modeling. Looking at the actual physics and dynamics of what goes on inside the GDT before and during a surge event helped Bourns designers significantly enhance the model GDT25 series. Taking the GDT design to the next level, our engineers evaluated the electric fields, as well as what shapes and materials were critical to improving GDT performance. Bourns also designed the model GDT25 series to be more robust with features that both help to spread the energy and ensure the energy transfers quickly. The model GDT25 device then went through extensive prototype testing, giving Bourns additional confidence that our engineering process had led us to a state-of-the-art design for a GDT. So what applications can best benefit from the surge performance advantages of the model GDT25 series? Well, the low-voltage models are ideal for industrial data lines, exposed power over Ethernet lines and coaxial systems, such as set-top boxes, cable modems, and antennae. Applications for low-voltage devices are the fastest-growing portion of our GDT business, and it's important to note that the 75-volt GDT25 model features one of the lowest breakdown voltages currently offered in the industry. Our 350-volt GDT25 models are excellent protection devices in classic telecommunications applications such as POTS, DSL lines, GFast modems, and routers. For the 600-volt GDT25 models, these devices make superior solutions on AC power lines when combined with a series MOV. The 600-volt model would also be applicable for industrial communication modules, building surge protection modules, splitters, and exposed Ethernet-based applications that don't use PoE. In a datasheet comparison of the Bourns NexGen model GDT25 family against a sampling of competitive benchmark products, the GDT25 series was best in class in nearly every measure. We looked at some of the characteristics that are important to most design engineers when they're selecting a GDT. Please notice that there is a helpful column in the center where it is easier to see that lower is better for some of these parameters, and higher is better for others. In every category, you can see that the model GDT25 beats the competition. Some of the benchmark ratings are misleading in that they are shown as a typical value, not a maximum value. When listed only as a typical value, designers have no assurances of what maximum values might be. There is a broader set of competitors offering 90-volt GDT products. A line-by-line analysis shows that the Bourns model GDT25-09 has a truly unique set of abilities. We offer 7 amps versus 5 amps by competitors, which is nominal for AC surges and lightning surges. Plus, the 10 killiamp one-time rating of the model GDT25 90-volt model is matched by a few, but it's well above others. Other feature advantages are shown with the capacitance level and also the temperature range, which both beat the competition. A comparison of 350-volt models tells the same story, where Bourns is at 650 and 800 on the spark-over voltages for high-speed lightning surges, and the competition is around 750 and 900 volts. Referencing the 10 by 350 surge rating that was presented earlier, the model GDT25-35 is rated at 1000 amps, while one of our competitors is listed at 500 amps. The others have no rating at all for that waveform. These comparisons show that the GDT25 350-volt models have a clear datasheet spec advantage. Likewise, the 600-volt GDT25 models continue to lead with datasheet specifications. For example, the Bourns model GDT25-60 is rated at 1000 to 1100 volts for lightning surges. This compares very well with the competition. In addition, this device offers the better AC surge rating, the better DC surge rating, the better 10 by 350 surge rating, the better capacitance level, and the better temperature range. No other 600-volt GDT has better datasheet specs. Now, some design engineers will want to see lab data to see the actual qualification evidence of the exceptional performance of the model GDT25 series, and we'll be making this data available to customers under NDA. A sample of what's in the report describes the 7000 amp lightning surge results, showing a graph of the model GDT25-07 performance. Prior to applying the lightning surges, we measured the DC breakdown voltage of a test group. That's shown in the blue shaded bars. After the 10 applications of a 7000 amp 8x20 test surge, the red bars show that the DC breakdown population has spread a little bit. It's drifted a little higher, but it all stays within the specifications. Similarly, when we look at the 10 AC power cross test results, we have an initial distribution in the blue. And after these operations, they tend to drift down just a little bit as shown in the red. But again, they stay within the specifications. This example shows the balance in the design. With the balanced approach Bourns engineers used for the model GDT25 series design, they were able to ensure that these surge effects are centered and the GDT doesn't drift out of spec in either direction. And that performance is remarkably consistent. We show this impulse protection as maximum values, so actual measurements will most likely be below that value. In our lab tests, we detect no drift in the DC breakdown voltage over time, and we see almost no shift in DC breakdown voltage after solder reflow. In fact, we performed the qualification testing after a simulated reflow, and everything stayed within datasheet specifications. The next generation model GDT25 series release and public announcement were issued in January 2021. To support these products, we've developed helpful sales collateral and marketing content materials. In addition to the press release, the new product brief and competitive cross-reference guide, we'll make design kits available so you can easily obtain a variety of all 4 GDT25 model samples. So Bourns has a full line of support to help you understand how the model GDT25 can fit into your customer's design. To summarize, the next generation model GDT25 series from Bourns offers a 40% improvement in standard surge current ratings from existing Bourns models. The performance delivered in Bourns' latest generation model GDT25 series helps to significantly improve protection against induced voltage transients, such as lightning and AC induction. Plus, specific models are available in several voltages that exceed the industry standard lightning surge current rating of 5 kA for a 5mm surface mount GDT. With the model GDT25 series, designers get excellent performance across a wide temperature range, low capacitance, and low insertion loss, making them an ideal protection solution for high-speed information and communication technology equipment such as set-top boxes, Ethernet, DSL, and GFast-based applications.